Welcome in the third section. We'll be focusing on the joins in distributed environment. So we'll see how to perform distributed joins in cluster. So in the first video, we will see how to avoid wrong join strategies. We'll be using a join type based on data volume. Next, we will see slow joins and how to choose an execution plan for join to speed it up. Third and fourth video will be about using newest Spark APIs for joins. Third one will be about data frame API, and fourth one will be if you occur the type safe joins problem. So newest data set API will give you joins, data frame syntax, and also type safety of the RDD and whole optimizations that are applied. And this is a first video in which we'll see how to avoid wrong join strategies. We'll be using a join type based on data volume. So we'll be understanding inner join, that this is a base for every join. So every dataset could be joined in this way. Next, we'll see how to compare left and right join and when to use which one. At the end, we'll be understanding outer joins and also we'll see a business value in it. So we have our join strategies class, and inside of it, we will be testing every strategy that could be applied on the RDD API. Because we need to understand how RDD is working, after we'll go to the higher abstraction, that is dataset and data frame. So let's consider two datasets. First is transactions and second is persons. So we have a transactions that has list of tuples. First transaction is, we have ID and some description of transaction, ID description, ID description. And persons, so those are users that perform the transaction. So we have an ID and name and so on and so on. And when you will compare those two data sets, you can see that in the first transactions, we have ID 1, 2, and 4. And in the persons, we have 1, 2, and 3. So there is no corresponding transaction for the person 3. And also, there is no corresponding person for the transaction 4. And this is often a case in the real-world data. But let's consider the simple join strategy that gives us RDD using the join method. If you are joining transactions on the join persons, we should get an inner join. Inner join is a specific kind of join that joins only data that is in both datasets. So in the resulting dataset, we should have a data for ID1 because this is in transactions and persons, and ID2. For 3 and 4, there should be no data when we are using just simple join method on this Spark RDD. So resulting dataset should have ID2, dog and Michael, so it means that Michael bought a dog, and 1 Tom bag, so Tom bought a bag. So let's start this test. We can see that our test passed, so it means that our inner join worked as expected. But often there's a case that we want to leave data from one dataset, and this would be that example. So here we want to leave all persons data. So even though Johnny has no transaction, we want to leave data for it, and as the transaction, that should be a non-type of Scala. So Scala has an option type. Option type has two possible values. One is none, it means that the value is not present, and second one is some. And when we will issue the right outer join, the data from the right hand side, so right hand side transaction that is passed to the argument, will retain in our result dataset, and data from the transactions will be presented as the option type. So it will not be a simple dog string as here, but it will be an option sum of dog. And let's examine the output. So we have a 2 and 1, similar as here, but right now there's a sum and sum. But Johnny has no transactions, so it will be presented as a none. So let's start this test. We can see that our test passed, so right join worked as expected. As you can imagine, also we have similar situation to that, but a bit different. So in this example, we want to leave all transactions and persons will be presented as the option type. So this one, car should retain, and it should have none persons assigned to it. So result is Doug, some Michael, Bug, some Tom, and car with none. And right now we are using left outer join. So right now the things that are the left hand side are live, and persons that are right hand side that has no join record in the transactions will be removed. So let's start this test. And we can see that left outer join work as expected. Last join, that is a complex join, more time consuming, is full outer join. That join takes all values and retains all values. So the expected output is like this. Both values that we are joining will be presented as the option value. So 2 has joined, so there will be sum of Doug and sum of Michael. 1 as well. But for 3 is different situation. We have none for the product that was bought, but person is present, so there is sum of Johnny, and 4 is otherwise. So we have a product car, but no person. So if we will execute that query, we will see that 4 records are in the result, even though only 2 have corresponding records in the different dataset. So if you are using joining, you should try to choose the proper operation, but also concerning performance. If you are joining your data and then you are filtering everything, for example, that have no product like this, then you should not use outer join. Maybe you should use right. But if you are filtering both, if there is none here or here, then you should use inner join, because your API will be simpler. You are not need to handle option types, and also join will be faster and will take less memory because that data is not so big.